Hi there, Mr. Sutton here, bringing you this lesson on factoring advanced trinomials. In this one, we'll be factoring trinomials for which the a value does not equal 1. For the warm-up, we have this expression that we're trying to factor. Pause the video and see how far you can get using the tricks and tools that you know so far. Alright, so maybe you thought about trying to figure out numbers that multiply to 120 and add up to 70. Unfortunately, that trick does not work if you have something other than a 1 next to the x squared. You might have also thought about trying to take out common factors. That's actually a pretty good thing to try here. In general, if a does not equal 1, if you have something other than 1 next to x squared, you should always try to take out the greatest common factor. So let's see here. The GCF for all of these numbers actually does end up being 10. So let's factor a 10 out of all of these. That leaves us with x squared plus 7x plus 12. And if this were a problem from a few lessons before, we might just stop here. And it turns out all those problems from the previous lessons could not be factored any further once you took out a common factor. However, we're at the point where we're going to start throwing some other types of problems at you. So at this point in your education, after taking out a common factor, you should be actively looking to try to factor what is left inside the parentheses. So take a look at what's left in here. X squared plus 7x plus 12. Is that something you think you can factor? If so, and if you didn't already get the answer, pause the video and try factoring the stuff inside that parentheses. Alright, now you might have noticed that the stuff inside, this is kind of like those earlier, easier problems that we saw where you had an a value of 1 next to that x squared. So now we can take a look at factors of 12 that add up to 7. And let's see here, that they have to both be positive because 12 is positive. So we have 1 and 12 doesn't work. 2 and 6 adds up to 8. 3 and 4 adds up to 7. So we can split this up into x plus 3 and x plus 4. The key here is you just have to remember to bring down that 10 as well, because the 10 is still part of this whole factorization. And just like before, if you want to check to see if this gives you the answer up here, you could multiply everything back out. But it takes a little longer to do it at this stage. We're moving on to another example here. And this is an example of what I like to call the hard case. We're actually going to do this one problem using two different methods. So pause the video and just take a minute to look at this problem and see why this is more difficult than what we did before. Okay, so just like before, the a value is not 1. We can't just ask what multiplies to -5 and adds up to -19. And unlike the first problem we saw, there are no common factors. We can't take a 4 out of everything, at least not unless we want to deal with fractions and decimals and things like that. So in this situation, when a does not equal 1, and you've already tried taking out a common factor and it's not happening, we move on to two other techniques, the first of which I like to call guess and check. So with this technique, what we're going to do is we're basically going to guess the answer, going to try to guess the answer. And when we do this, we're going to pick two factors that are going to give us both the squared term and the constant. So if I have my two parentheses that multiply to give me this stuff, just kind of thinking backwards here, what I would have to multiply to get this. To get a 4x squared, assuming both terms have x's in them, there's really two ways to do that. You could do x times 4x, and you could do 2x times 2x. I don't know which one is the answer, so I'm just going to guess 2x and 2x in my two parentheses. It might be the right answer, it might not. We will see. Now we also have to have numbers in here that when I multiply the last terms together, the constants together, I get this -5. So again, I don't know what the answers are, but there aren't a whole lot of factors of -5, so I'm just going to guess +1, and if I guess +1 here, -5 is going to have to go over here. So I already know that if I multiply this out, I'm going to get a 4x squared for the squared term and a -5 for the constant term. That's great, but am I going to get a -19 when I multiply the outers and the inners together and add those together? I don't know. So my next step is I'm going to test to see if those outer and inner products actually add up to this x term in the middle. So we've got 2x times -5 for the outer term. That's -10x. And 1 times 2x for the inner term gives us +2x. And if I combine those, that adds up to -8x. That's not -19x. That's not what we were looking for. So if you don't get the middle term here, you have to keep repeating this process until you find factors that actually work. So this didn't work out. Let's try something else. Instead of trying 2x and 2x, I'm going to try 4x and x, and I'll still have plus 1 here and a minus 5 here. So I'm only changing the x terms there. Now if I multiply these out, 4x times negative 5 is going to give me negative 20x. 1 times x gives me 1x. Negative 20x plus 1x adds up to negative 19x. And hey, that's exactly what I was looking for. So that means I just found the answer here. And in terms of showing work, you just have to show that when you actually multiply your answer out, it does give you that middle term. So for my answer, I'm just going to write 4x plus 1 and x minus 5. So here's another example, and you might recognize this problem. It's actually exactly the same as the trinomial that we just factored using guess and check. I'm going to do this one now using a different method. Guess and check is great, especially if you have like prime numbers like 5 for one of the constants or for the a value here, but you don't always have that situation. And if there's a lot of different possibilities and combinations, it's very easy to lose track of what you tried and haven't tried if you're not very organized. So this method, which I call the AC method, and you'll see why in just a sec, is a more step-by-step methodical method that's pretty much the same method every single time. There's really no art to it. It's just practice these steps and do it over and over again. So to start with, we need something in ax squared plus bx plus c form. We want this nice little quadratic form here. And our very first step here, which isn't going to make any sense except for the fact that I'm going to tell you it works, it's part of the process. Our first step is to multiply the a and the c value together. So this 4 and this negative 5, we're going to multiply them together. And in this particular problem, that gives us negative 20. Okay, so you might be wondering why we're doing that. And the long and short of it is, when we were factoring by guessing and checking, we had to worry about the factors of 4 and 5 together. By multiplying them together, we're essentially just lumping it all into one place. So now we only have to worry about factors of negative 20. So what we're going to do at this point is we're going to find factors of that AC value we just found, negative 20, that add up to that B value, that term that's next, that number that's next to the X. So this is kind of like putting us back to where we were when we just had an A value of 1, where we just found factors of the constant that added up to the middle number. Only this time it's factors of this AC value that add up to this B value. So what multiplies to negative 20 and adds up to negative 19? So going through the combinations here, we have 1 times negative 20. That would give us negative 20 by multiplying. Does 1 plus negative 20 add up to negative 19? Oh, actually it does. So this is cool. We found it on the very first try. We're not always going to be that lucky, but there it is. So once you've found your magic factors, what do you do with them? So now what we're going to do is we're going to split up that bx term, that linear term right here, into the two factors with x's on them. So instead of writing a negative 19x here, I'm going to rewrite this as 1x minus 20x. So I'm taking these two factors that satisfied this condition and splitting the x term up into those two factors. Now, why am I doing this? This makes it look less simple. Well, what I'm going to do, now that I have 4 terms, hey, remember what method we can use when we have 4 terms? We can try factoring by grouping, and that's exactly what we're going to do here. So we've got, let's see, an x that we can take out of those first 2 terms. That leaves us with 4x plus 1 inside. And for the next 2 terms, I can take a negative 5 out of those, leaving me with a 4x plus 1. And since these both have a 4x plus 1 factor, I can take that out as a common factor, and that leaves me with x minus 5 inside the parentheses next to it. And there we have it, exact same answer we got using guess and check. To close things out here, we'll do one more example just to let you practice the techniques you've learned so far. So pause the video and give this a shot using any method you think will work. Okay, so first thing we notice, we don't have an a value of 1. And if you look to factor out a 2, you're going to find that we can't do that because of this 15 in here being odd. So that means we have to use either guess and check or the AC method, factoring by grouping. So guess and check might have worked out for you. If it did, that's great. I'm going to show you the AC approach. So I'm going to multiply 2 and 18 to get an AC value of 36. And now I'm looking for values or factors of 36 that add up to negative 15. So because 36 is positive, I know they have the same sign, and they add up to a negative, so I've got two negatives I'm looking for. So let's see here. 1 and 36 adds up to 37. 2 and 18 adds up to 20. 3 and 12, that adds up to 15. So I need negative 3 and negative 12. So I'm actually going to split this up then into negative 3x minus 12x for my next step. So again, with the AC method, notice that when you find your factors, you're splitting up this middle term rather than putting those numbers in a parentheses with x's like we did before. So slightly different process. But now I'm going to go ahead and factor this by grouping. So I can take an x out of these first two terms, leaving me with 2x minus 3. And I can take a negative 6 out of these next two terms, leaving me with 2x minus 3. Now I factor out that 2x minus 3 that they share, and the x minus 6 leftovers go into parentheses next to it, and this thing is factored out. For the wrap-up on this one, pause the video and take a moment to write down which method you prefer, guess and check or AC, and why. All right, now for my 2 cents on this one, I think they're both useful in different situations. Guess and check is great if you have a simple problem with only a couple possibilities that you have to check, and there's no process to memorize, so there's definitely that going for it. AC is a little bit more involved with that process, but it's really great for problems where there's lots of possibilities. The nice thing about AC is that if you practice it, you can become really efficient at it, and it always takes about the same amount of time. So just different things to think about. Till next time, Mr. Sutton signing off.